Hello, and welcome to the first webinar presentation by the Underground Construction Association Young Members Group. My name is Erin Clark, and I am one of 3 members of the new UCA of SME Standing Committee for the UCA Young Members. I am the Professional Development Chair, and I am joined by Anthony Bauer, the Chair, and Shannon Goff, the University Outreach Chair, in welcoming you to today's presentation. Before we get started, I'd first like to introduce you to our group and our mission. We are a group of professionals and students of all ages with a common interest to grow and develop the population of engineers and construction professionals under the age of 35 within the underground industry. Throughout the year, you can join us for monthly webinars and stay involved in the conversation by visiting our website at community.smenet.org/UCAYM. At the annual RATC and NET conferences, we will host a networking event for students and professionals under the age of 35. At our monthly webinars will be hosted on the last Wednesday of each month and are free of cost thanks to the generous support of the UCA Division of SME. Next month, join us on March 25th to hear Eric Wang of Jacobs Engineering talk about overcoming the challenges based on the construction of the MTCAC East Side Access Project in New York City. Today we will begin our webinar series with a presentation by Bill Edgerton on the excitement of working underground. Bill is a principal at McMillan Jacobs Associates, has more than 40 years of design and construction experience. He received his bachelor's in civil engineering at Tufts University in Medford, Massachusetts, his MBA in procurement and contracting at George Washington University in Washington, D.C., and holds PE licenses in 9 states. During the first 17 years of his career, he worked for construction contractors on various heavy civil, highway, transit, dam, bridge, marine, process, and power plant projects throughout the eastern United States. In 25 years, he has worked for Jacobs Associates. He has represented both owners and contractors on a number of heavy civil and tunnel projects. As construction manager on wastewater treatment plants, transit, and water tunnels, and as a designer on water, wastewater, and transit tunnels. He has worked on design build and design bid build projects for both contractors and for owner agencies. Bill currently serves as the manager of tunneling for DC Water's Clean River project in Washington, D.C. Today he will be presenting on several key components of the planning for and status of DC Water's $2.6 billion CSO control program in Washington, D.C., along with some personal advice. Thank you, Bill, for joining us today as our first presenter. When you're ready, please share your desktop.
Okay, I think you all should be seeing my desktop now, and assume that's the case. So good afternoon, everybody, and thanks for joining the first webinar for the Young Tunnelers Group. The 3 sponsors of today's session are McMillan Jacobs Associates, DC Water, and the Underground Construction Association of the USA. The agenda today, what I'm going to do is I'll give you some personal information. Actually, Aaron just gave you most of my personal information. Talk a little bit about the UCA of SME, a little bit about tunneling in the nation's capital, and some thoughts about making a career underground. So most of this slide, Aaron already talked about. My work experience is shown there. And just another note here, most of my life has been done at the project level. I've gone around, moved around in various different locations around the country. I think I counted up the other day, I have 21 separate moves. So my wife hasn't always liked that, but in any case, we have done it 21 times. And I think she mentioned my career developed from heavy civil construction to tunnel design and CM, and I've done quite a bit of dispute resolution in there as well. Seems like you have to do that in this business. So what is the UCA of SME? Well, the Underground Construction Association is an individual membership association consisting of contractors, engineers, suppliers, owners, and academia. We do have corporate and sustaining members, but those members really are a group of individual members. There's about 1,000 members in the UCA. I think the current count is about 1,170 or so in U.S. and Canada. And we are the U.S. representative to the International Tunneling and Underground Space Association, sometimes called the ITA. And that's, ITA has meetings every year in some place around the world, and they're quite interesting. We should have a webinar on the ITA sometime in the future. I've put the mission here of the UCA on the bottom of the slide. Our mission is to promote the responsible development and use of underground space and facilities. So what do? We have a quarterly magazine, Tunneling and Underground Construction. There's an online library, onetunnel.org. We have annual meetings, and even meetings at the NAT conference, most recently in Portland, Indianapolis, and the most recent one in Los Angeles. In odd years, we held them at the RATC conference. The next one is going to be in New Orleans here in June of this year. There are multiple track papers and exhibits and short courses held at these annual meetings. We usually get anywhere from 900 to 1,400 people in attendance at these meetings. We do give out individual scholarships and some conference scholarships. There's networking and mentoring opportunities at these annual meetings. And we do have regional conferences every year. The Fox Conference, for instance, in January in New York, and the Cutting Edge Conference in some other city. There's a Cutting Edge Conference coming up in September in Denver this year. We had a strategic planning session last November, and we came up with 3 strategic goals for the UCA. We want to become the primary resource for underground construction issues and information requests. We want to improve the image of the underground construction in the minds of the public, government, owners, and all key constituencies. And we want to improve the effectiveness and efficiency of the underground construction industry. Right now we have strategic panels, committees working on each one of these strategic goals, and we expect to have an action plan put together by the RATC conference when we gather down in New Orleans in June of this year. So let's talk about tunneling in the nation's capital. And I'm going to talk a little bit about an overview of the program, some of the tunneling and geotechnical planning that went on, how we put our RFP documents together, and some structure protection, a little bit on construction management, and a little bit on program controls. So this program, the facility plan, was done in 2005 to 2008 by a joint venture of CDM and Halcyon McDonald. And the program managers currently, starting in 2009, Greeley and Hanson and McMillan Jacobs Associates. So CSO, the challenge we have, CSO is combined sewer overflow. I think most of you understand that. In the District of Columbia, about 1/3 of the area is combined sewer facilities. The rest of it is separated sewer facilities. We have 53 CSO outfalls along 3 receiving waters, the Anacostia River, the Potomac River, and Rock Creek. The single largest overflow is into the Anacostia River, where there's about 2 billion gallons a year out goes into the Anacostia River. In about 82 times a year, roughly, there'll be an overflow. So it's basically almost every time it rains, there's an overflow into the Anacostia River. There's also a lot of flooding that goes on in the northeastern portion of the district, and you can see some of these pictures here. The flooding is so severe due to undersized storm sewers that people's cars and houses get flooded when it rains a significant amount. And this can happen anywhere from 1 to 3 times a year. Most of the sewers in the city are undersized, at least in where the topography in the northeastern boundary section of the city. There is a lot of flow. So the solution that's been developed is a series of tunnels, both along the Anacostia River, shown in this slide in red, and along the Potomac River, shown in this slide in yellow. There's another CSO system up in the Piney Branch which we may or may not do as a tunnel, we may do as the infrastructure. There are a number of pumping station rehabilitations shown in this slide as a P. And the total value of this project is about $2.5 billion. And then there's a nitrogen removal system going on in planes as well. We have a 20-year implementation cycle, supposed to be done by 2025, and will result at the end of the day in about a 96% reduction in CSOs, as well as flood relief in the northeastern boundary part of the tunnel of the city. So there was a consent decree. The consent decree was signed by the EPA, the Department of Justice, the District of Columbia Government, and DC Water. Was entered into the district court in March of 2005 with a 20-year schedule. That's where the 2025 consent decree date comes from. There were many interim deadlines, one major one in 2018. I'll talk a little bit about that later, and significant stipulated penalties if these dates were not met. Along the Anacostia River side, there's a series of controls, and see, this slide is a little busy here, but on the right-hand side, the tunnel system starts with blue plains down in the lower part of the screen, the letter Y, and goes alongside the Potomac River and crosses the river. The blue line there is the Blue Plains Tunnel. The orange line is the Anacostia River Tunnel. The green line there is the Northeast Boundary Tunnel. Way up in the northern part is the First Street Tunnel. And that's all of those tunnels, 4 major tunnel areas are currently in either procurement or in construction. So the next slide shows the schedule. And the Blue Plains Tunnel is currently scheduled to be done in 2015. The Anacostia River Tunnel in 2017. The First Street Tunnel in early 2016. And then we're in the planning stage right now for the Northeast Boundary Tunnel, scheduled to be done in early 2022. I'm not showing on this slide the schedule for Potomac River and RFP projects. They're actually pending change to the consent decree date, so we won't talk about that anymore today here. I'm going to a little bit of detail on the Blue Plains Tunnel. The Blue Plains Tunnel is a design build. 23-foot diameter soft ground for an EPA machine, about 100 or so feet under the surface, 23,000 feet long, includes 5 shafts. The contractor is Greller Brothers with Skanska and JD. It's a joint venture. Their designer is Halcro, and the contract value is $330 million. And as I think I mentioned before, they're scheduled to be complete in November 2015. As of today, they're 76% complete with the mining right about up here where my cursor is located, just south of Poplar Point area. There's a dewatering and a screening shaft at Blue Plains. This aerial shot is taken over the Blue Plains treatment plant. It's a relatively large dewatering shaft. You can see here it's 135 feet in diameter and about 176 or so feet deep, all in soft ground. Very complicated shaft, both design and construction-wise. This facility in the back here with the pier is the Navy Research Lab. So Blue Plains is located just south of the Navy Research Lab on the Potomac River. Next slide is a couple other photographs showing the dewatering screening shaft in the air, the TBM cutter head, and then looking down the dewatering shaft slurry wall. This is a photograph of the thermal boring machine that's currently being used. It's nicknamed Lady Bird. This photo was taken at the Herrenkonecht factory in Schwanau, Germany, before it shipped over here. So this is a couple of shots of assembling the Lady Bird thermal boring machine. This is down in the hole. The machine went down in the hole in 3 pieces. The cutter head, which you can't see back here, the tail shield, and the main body of the shield. This crane that set the machine down in the hole is a 660-ton crane, and I think they told me the largest piece was 475,000 pounds. So this is a shot of the precast liner segments currently in production at the town of Brandywine, Maryland. It's about 30 miles south of the district, and you can see some of the craft people finishing the top of the segments down there. So this is a current schedule, current as of the end of December, for the Blue Plains Tunnel. We're currently about along in here somewhere, about, as I said, 76% complete. Scheduled to be done in mid-2015. A little tunnel cleanup and substantial completion in late 2015. Virtually every single one of these sites along the alignment will be turned over to another contractor for their work at the end of the Blue Plains Tunnel project. The next contract that I want to talk about is the Division H, what we call Anacostia River Tunnel. It's also a design build project, the same internal diameter, 23 foot. Mostly EPBM. There is a small NATM component at just south of RFK Stadium. The depth is about 100 feet. It's 12,500 foot long. There are 6 slurry wall shafts along the alignment. Currently in construction by a joint venture of Intergelo, Healy, and Parsons. The designer is Parsons. Contract value is $254 million. They got NTP in June of 2013 and completion scheduled for 2017. This next slide shows an animation that we did to show how the tunnel slides underneath a number of pile-supported structures along the alignment. I'll talk a little bit more about structure protection later and show you some cross-sections, but this will give you an idea of some of the forest of piles and other structures that we go under along the alignment. The next tunnel is the First Street Tunnel, which is up in the northern part of the city near McMillan Reservoir. If you're familiar with McMillan Reservoir, this is McMillan Reservoir here, a source of water supply for the district. It's a design build, what we call design build hybrid, in that some of the structures were fully designed, but others of the structures, the tunnel and shafts, the lining were design build. We required a 19-foot minimum diameter. I think the contractor actually is finishing slightly more than the 19-foot minimum. It's anywhere from 80 to 160 feet deep. There's topography in this part of the city, so the start shaft is up in the up on a hill up here, so it's 160 feet at the mining shaft. There are 4 shafts and 3 diversion structures. There's a 10 MGD pump station at the lower end, and that pump station will pump out the tunnel after a rainstorm and put it into the normal sewer system. The adits and freeze will be done with freeze method, and those freeze is currently underway now. More trenches, the contractor will put the freeze for the joint venture of Skanska JD, who is the contractor. Their designer is Parsons Brinkerhoff. Contract value of this is $153 million. We gave them notice to proceed in October 2013 and completion scheduled for early 2016. So this is a cartoon of the residential neighborhood in the area of First Street. This was taken along with Flagler Street to give you a pretty good idea of how near to residences this construction in the street is. Basically, the construction in this neighborhood goes curb to curb, so there's a lot of coordination necessary with the residents up there. And we did quite a bit of that during the design phase, and the contractor and the construction manager are dealing with that every day up there now as this work is currently going on. Our next contract is the last major tunnel contract on the Anacostia River is Division J, the Northeast Boundary Tunnel. It will be a design build, 23-foot diameter, soft ground, anywhere from 50 to 160 foot deep. This will be the longest tunnel, 27,000 foot long, with 6 shafts and diversion structures along the alignment. It'll be mined from down here just south of RFK Stadium. That will be the mining site, and it won't start until the Division H contractor, the Intergelo Parsons venture, is off the site. That's when we'll turn the site over to the follow-on contractor who will mine north out of there. It's currently in planning. The RFQ will go out the 4th quarter of this year. We'll get a contract value pegged somewhere in the $500 to $600 million range. notice to proceed in 2017, as I said, after Infantry Parsons moves off of the site, and completion in 2025. The next slide shows a hydraulic profile of the system. We're required by consent decree to provide 157 million gallons of storage, and that storage is achieved by water in the tunnel up to an elevation of -24. If it keeps raining, the rain will keep going into the tunnel until such time as the tunnel fills up to an elevation of about +3, and then it will overflow into the Anacostia and the Potomac River at several overflow structures along the alignment. We have a couple of different types of drop shafts along the alignment. One is what we call an inline drop shaft, and these inline drop shafts are about 55 to 75 feet in diameter. And the idea here is that the tunnel boring machine will mine into the drop shaft and it will be used as TBM maintenance. And then after the tunnel is all mined, the internals go in these drop shafts and essentially operate as the water will drop down the drop pipe and kind of go around this deaeration channel to release the air. It'll drop over the edge here and go down into the bottom where it goes into this orifice. These drop shafts were modeled at the University of Iowa, so we know that they will work okay. The other type of drop shafts we have for less volume of flow is the offline drop shafts. And these offline drop shafts are for smaller flows from the diversion structure through the approach channel, down the offline drop shaft and through an attic. And they'll deaerate in the offline drop shaft and through the attic. So that's how the air gets out in the offline drop shafts. Okay, so I was going to talk a little bit about the tunnels and the geotechnical planning involved in the project. The horizontal alignment was basically, this is some of the criteria we used for horizontal alignment. We wanted to have it near existing CSOs and pumping stations. We wanted it away from underground features such as the Navy Research Lab Tier and various DoD storm sewers at the Bowling Air Force Base alignment. We wanted space for intermediate shafts where we have these online drop shafts. We wanted space for the contractors to work. We followed public rights-of-way wherever we could to minimize the amount of easements necessary. And we wanted to cross railroads where we crossed them. We wanted to cross them at right angles. We weren't always able to do that, but we did, for the most part, cross both CSX and the WMATA lines, the local transit lines, at right angles. We held a criteria of the minimum radius of curve on the tunnel as about 900 foot plus or minus. I think we're down to 870 feet in some areas, but we didn't want to go much tighter than about 900 foot. And we tried to hold a tangent into and out of the shafts to make it easier for the contractors to come in and out of the shaft without having to worry about turning curves. On the vertical alignment, we had the pump station to go to at Blue Plains. We wanted a minimum grade of at least 0.1%. The depth was actually determined by getting under stuff along the alignment, and that stuff is bridges and DC water sewer systems and even DoD sewer systems, many of which are on piles in the soft ground. The working depth of the tunnel was limited to 3 bars, and that was primarily to make the interventions easier and less costly. And we did not chase the ground. We put the tunnel at those locations with that criteria, and we didn't try to go up and down and find the ground. I'll have another alignment slide a little bit showing some geotech listening. This is an example of some of the cross sections along the alignment. The slide might be a little hard to read, but basically we're going under a forest of piles for many of these sewer systems, and we parallel some other sewer systems along the alignment. So we evaluated the zone of influence and what sort of ground subsidence we might see with a certain amount of ground loss in the TBM, and that was all done in the preliminary engineering phases. So here's the promised geotechnical slide. This is Geological Investigations. The policy that we had was to have all these geotech investigations done by the owner prior to the bidding phases. That is, we didn't push any geotech investigations to the design builder. They could, during the bidding period, request additional borings, and in fact, they did, and in fact, we went out and got some. If they decided that we didn't have enough information for what they wanted to build, we did go out and get some more holes. We did several at each shaft location. We did some pump tests, both at the Blue Plains and at RFK Stadium. We found actually some flowing artesian pressures on the north side of Anacostia Road. It ranged from about plus 14 to plus 20 in the ground units and then plus 13 to plus 16 range in this area. You can see in this geological lithography here, the green, the darker green is the Patapsco Arundel Formation, which is mostly clays and silt. And the lighter green at the bottom is the Patuxent Formation, silty clays and sands in the lower levels. We're overlaying on the top with some fill and some alluvium that you can see up on top. Just for some figures here, the exploration program, we did 242 geotech borings along the alignment. It cost about $9 million drilling costs and a little over $500,000 in lab testing. We had some geoprobes, mostly for environmental, and geoprobes was a lot less in drilling costs, but substantially more in lab costs due to the lab tests we were running for chemistry permits and waste disposal of that environmental borings. So now I want to talk a little bit about RFP documents and structure protection. So from the facility plan drawings that were done by the CDM Hatch joint venture, we advanced the design to 60%, to 90%, and 100% before we released them for bidding purposes. That effort was about 18 months for each of the segments. We used input from our project review board, both at the 60% and at the 90% level. That's kind of like a technical review committee. It consisted of Ed Cording, Roger Ilsley, Rippenprop, Jim Brady, Jim Hagens, and they came in at those time periods to give us advice on whether we were on the right track or not. We did have to modify our general conditions to revise the standard DC water general conditions from a design bid build to a design build method. The RFQ was scheduled to be complete and shortlisted firms identified when the RFP was ready for release, so we timed it that way. And we established certain mandatory requirements in the RFP documents, and the drawings would show horizontal and vertical alignments and other mandatory geometries, mostly relating to hydraulic requirements. The wall thicknesses and reinforcing steel was left to the design builders. And I'll talk about design criteria here on the next slide. This slide talks about the specifications. The Division 0 specs have the standard bidding instructions, contract forms, and all general conditions. In the general and special conditions, we included a baseline report. We changed the retention practices, we had certain payment provisions. We included partnering a dispute resolution process, DRBs, escrow bid documents. We had an owner-controlled insurance program. We had changes in the differing site clause, and we changed some of the warranty provisions. In the Division 1 section, the criteria, design criteria provided included the design life of 100 years, the loading criteria and combinations of that criteria, the seismic criteria, certain limitations on shaft methods that were acceptable. We specified certain factors of safety that had to be used, technical parameters, the leakage requirements, and the hydraulic structures and certain equipment that was be necessary. The Division 1 section is where the requirements are for how the design is advanced, what permits the owner had, what permits the design builder was intended to get, the various contract interfaces, temporary facilities, health and safety, environmental stuff. The technical specifications we call Category 2 and 3 were able to be finalized by the design builder. Some of the Category 2 specs included a tunnel boring machine or jet grouting or something like that, where there were certain prescriptive elements included in the specifications, the outline specs that we gave to the design builders. They were to fill in the rest of them. The Category 3 specs were basically DC water standards. And those are things like cast-in-place concrete and hydraulic equipment and those sorts of things. The design builder's engineer of record was to devise those and track changes, tell us what he was changing and track changes so it would be approved eventually as the RF release for construction documents were produced. On the geotechnical front, we had a GBR. The tunnel had functional baselines with some geotechnical components, primarily for abrasivity and stickiness. The shafts were baselined by borings at the shafts, and we had environmental baselines. Basically, the depth of contamination was specified. I don't really have time to talk much about functional baselines, but there was a great paper on functional baselines given at the, I think it was a RATC conference in DC here a couple of months ago. So look up functional baselines in onetunnel.org and you can get a good idea of what the functional baselines are all about. We also did turn out in GDR with boring logs, lab results, and groundwater and soil chemistry as well. I want to talk a little bit about protection of structures. The RFP documents identified the utilities and the various structures that the lines were going under. I showed you a cartoon of that, an animation of that before. We required the contractors and the designers to do construction impact assessment reports, which required both modeling of soil movement based on their means and methods of construction and structural modeling to see whether the structures were going to see any distress because of that. So this picture here is a picture of one of the relatively large sewers that were going under. Some of these sewers, this one in particular, was built in the early 1900s, 1901, 1902 area. Anyway, so the design builder's engineer modeled these structures using numerical modeling method. He used the site-specific soil parameters, lab data, in situ soil testing from the GBR and from the GDR. The soil movements were calibrated empirical methods using a certain volume loss, both for the tunnel and for the panel and the various shaft excavations. The result of all that soil modeling was some ground movements that could be expected given those excavations. And so he modeled this and came up with a certain amount of ground loss that these structures may be able to be subject to. So then he took that ground loss and went into a structural model, and given the actual capacity of these structures, we actually went into these structures and took some cores and using statistical analysis evaluated what the strength, concrete strength of these of these existing structures were likely to be, both at the base of the walls and the arch, and concluded and ran these movements into this structural model and determined that in several cases we're going to need to do some sort of mitigation of these structures. One of these mitigation measures turned out to be ground improvement, and you can see Hayward Baker's equipment there doing some soil cement columns in one area, and we also did some structural rehabilitation, some bracing inside one of our existing sewers. You can see here on the left, it's a relatively large sewer that was going to see some distress if we didn't do some bracing systems. The payment approach for this was we did not expect the contractors to carry this mitigation, the cost of this mitigation in the bid price. We did cover the cost of construction of some of these mitigation items as an allowance item, and that's how we paid for it. This is a slide shows the design that came up with for the soil mix columns in protection of one of these sewers that we decided was going to see some distress if we didn't use some soil mix columns. So this is the soil mix tool that was used in the Hayward Baker method here for soil cement. Some of the columns were the 8-foot diameter, some of them were smaller, 2 or 3 foot diameter, right up next to the existing sewer. And we think it worked because the soil cement went down about 50 feet below the ground, down through the fill and through the alluvium. So this slide shows the result of some equinometers that were installed, and you can see in the lower Potomac Formation, where we do not do the soil cement, we got movements in the 0.2 of an inch range, and up in the upper levels where we did do the soil mixing, we got less ground movement as shown by these inclinometers. So we think it worked pretty good. We're quite happy with the results. I'll talk a little bit about construction management. There's a whole laundry list of things that our construction management teams do on the site. We have separate contracts. DC Water holds separate contracts with the construction managers. That's not part of the program management. During the pre-bid award and bid award phases, a lot of coordination on scope development, master program schedule, constructability reviews, permitting and rights-of-way, bid and award assistance, and developing procedures. During construction, there's an immense amount of contract administration goes on. The CM is the primary point of contact with formal correspondence with the contractor. That firm manages the partnering and the dispute review board processes. It manages all the pre-construction conferences, enforces the terms of the contract, schedules the periodic meetings, reviews and processes pay requests, documents the work done every day, manages the document control system. The schedule management, the CM provides input to the program master schedule, reviews the contractor's baseline schedules and the schedule values, reviews the contractor monthly updates and revisions thereto, monitors work progress, and reviews the variances and variance recovery schedules as necessary. Construction safety, the CM does an oversight of the contractor safety program. Contractor is still responsible for the safety. The CM coordinates with the local public safety agencies, the owner safety department, and there's the owner-controlled insurance program that does have its own safety people doing inspections as well. It assists with safety audits and develops, implements, and manages the construction manager's own safety. There's a quality program as well. Both the contractor and the CM have quality programs. The contractor quality control submits a contractor quality control management plan and a design quality management plan, which includes third-party inspection and testing. Quality assurance is done by both the contractor for their program and by the construction manager, provides oversight inspection. There's QA, QC tracking and reporting, both by the contractor. The QC manager may issue a non-conformance notice, and they would identify when and if that non-conformance would require the engineer record to look at it and say, okay, it's not built this way, you need to do X, Y, and Z to it. So those are all stipulated in the specifications for quality control. On the program control side, the objectives of the program control are to meet the consent decree milestones for design construction, execute the design construction and design build contracts on budget, manage the funding, and inform the decision makers, the owner side, on progress. That's basically what our program controls is to do. They use various tools to do that. On the schedule control side, they monitor the program schedule contingency, and that's what this chart here on the left is intending to show. We have a certain number of days of programic float, and we expect to have to use up that program float as the job advances. And then there's a standard Primavera schedule there on the right-hand side. We do monitor many of our contract interfaces using a linear schedule, and the linear schedule is shown on the next slide here. And I know there's a lot more information on there than you can see, but time on this chart starts at the top and advances on the way down. So this is a consent decree date at the bottom. The stationing along the alignment is along the horizontal axis here. So you can see these sloping lines. Sometimes these linear schedules are called sloping line charts. The green line here belongs to the Blue Plains Tunnel. The orange line belongs to the Anacostia River Tunnel. And these vertical bars are structures at specific stations along the line. So we monitor, we find that the graphic illustration of schedule is really quite useful. So I'm going to switch gears here a little bit and talk about making a career underground. Clearly, there are a lot of different possibilities for careers in the underground industry. So I've got some advice here on the following slides. Making the most of college. Take English and economics and human capital. Don't forget that when you're out there in the real world, you're really going to be dealing with people. And it's important to learn how to get along with people. Engineers just don't sit in a room by themselves and take the information out of their in basket and put it into their out basket. Recognize you get a lot more from projects than you will from classes. Appreciate the projects that are multidisciplinary. The schools will want to establish multidisciplinary projects, and that's just because that's the way we do it out there in the real world. And deal with a lot of people that are of different disciplines. If you plan to go into the design world, you probably in the underground industry need a master's degree to do that. If you want to go into construction into the business, there's a lot of opportunities there, or construction management. In my opinion, a bachelor's is fine for that. And probably the most important advice there, take the FE exam while you're still in school, because if you wait until several years later, it's really hard. The first job, don't be too picky. Align your personal and your professional goals and dreams. Use your capacity to learn, and especially try something new or move to a different location. I've moved around a lot. I like moving around, but it is useful to move around to a different location and see the country, see the world, and learn how things get built. This cover of this book, Practical Tunnel Driving, has been out of print for decades now, but Richardson and Mayo is an excellent book, and if you can get your hands on it, and it's very practical on how things get built, I'd suggest that would be an excellent book to page through and read from cover to cover. Moving on up, get a credential, either a professional engineering certificate or a construction manager certificate, CSI certificate. Keep learning. Continuing education is very important, and don't forget to maintain those records. Some of these states require you to maintain records, and if they audit you, to turn in the records. So make sure you keep them up. I always think that people should be an expert in something. Find something you're really interested in and become known as that expert inside your own firm and maybe even outside your firm. Don't be too eager to manage stuff. People always want to be a manager. You need to have a certain amount of background in actually doing stuff before you can manage other people doing stuff. So don't be too eager to do that. Look for a number of different bosses. You'll see how different people react and how they supervise, and I think it's very good to work for a number of different people. Network with people in the industry. Stay connected to academia, not only for your own benefit, but for the benefit of academia as well. And the keys to success, and I think this is my last slide, in any profession really requires knowledge. A lot of that knowledge you get in school requires skill by actually doing it, and requires judgment. And as Mark Twain says, good judgment comes from experience, and a lot of experience comes from bad judgment. So knowledge, skill, and judgment in just about any profession. And to keep your sanity, enjoy what you do, like the people you do it with, and above all, do something that matters. So when you go home at night, you can say, I did something that matters today. And I think that's the end. I put my email address there on the bottom of that slide. So any questions? That would be
Bill, this is Heather from SME, and I would just like to say thank you so much for that wonderful presentation. At this time, I'd like to invite attendees to use the chat panel to submit questions, and I'll read them off so we can capture them in the recording. While we're waiting for some questions to come in, I'd just like to remind everybody that today's session was recorded, and I'll be sending out a link within the next 48 hours so you can view and download this session as well. Bill, I'm going to go ahead and read the first question.
okay.
The first question is, how is the tunnel muck disposed of?
Okay, so the tunnel muck comes out of the tunnel and goes in trucks, and it's trucked to landfill sites, and most of the landfill sites are south of BC, about 10 miles or so, and there's a number of different sites, so that when one of them gets closed because of environmental issues or mud on the road or whatever, there's another site that the contractor can go to.
Great, thank you. The next question reads, with similar tunnel diameters, are the EPBM expected to be refurbished between contracts?
I would expect them to be refurbished between contracts, yes. Now, currently, the 3 tunnel contracts all have different machines because of the timing. The last tunnel contract that we have out there, the Northeast Boundary Tunnel, will be the same size, and I would expect maybe some of these existing machines would be able to be used on that last drive after being refurbished. We're not going to prohibit it in the specs.
Great, thank you. That appears to be the end of the questions for now. I'd encourage our attendees to please use the email address on the screen here to reach out to Bill. It does look like we have one more question coming in. Let's see here. Over the course of your career, what has been the most challenging project that you were involved with, and what was the most satisfying?
I think the most satisfying one, probably the very first job I did out of undergraduate school, because it had a lot of different pieces on it. It was a dam. It was a dam in upstate Pennsylvania for Pennsylvania Gas and Water Company. And it had just about everything on it. It had rock excavation and earth excavation and dam and concrete work, and it had just about everything on it. So I think that was probably the most satisfying. The most challenging is probably the inland feeder job, the Arrowhead Tunnel down in Southern California. I'd have to say it was probably the most challenging.
Great, thanks, Bill. The next question reads, what are the job prospects for PhDs in tunneling industry?
Well, you know, PhDs can obviously find work in the underground industry. They can find work in academia, and also, you know, for consulting firms. I suggested in one of my slides that to work in the design area, you need at least a master's degree. That's not to prohibit PhD students from working in design. I guess just my opinion is that a PhD is not necessary, and frankly, I think that some field experience it may be at least as important as staying in school and getting a PhD, unless you plan to teach. And if you plan to teach, if you like teaching, then get a PhD, go into the field and get some real-world experience, and then go into teaching. That's probably a good career path.
That's great, Bill. I apologize for the delay. We've got a lot of questions coming in now. Let's see, the next question was, how has DCCRP's experience with design-build contract delivery method changed your view of design-build's value?
That sounds like a curveball question. You know, I think that one of our issues on the job, and it's not, is that some of the designers, there's a lot of design work associated with these design-build jobs, and what we have required of the designers to do maybe a little more than what other design-build contracts require the designers to do. There's a lot of submittal process to go through. I believe that we explained that in the contract documents, but it may be different from what design-build teams are used to on other jobs. And I guess some of the things that we may do differently in the future is we might draw attention to the fact that this is what we're expecting. We may draw attention to that during the pre-bid phase so that the contractors go into the job knowing exactly what we expect. And we may not have drawn attention to it enough on the jobs that we have going so far. So that's one of the things that we're going to try to do differently as we move forward into the next contract.
Great, thanks, Bill. The next question, for this project or in general, how often do you see unexpected events and what measures do you usually take as a first responder?
You see unexpected events on every project, usually multiple unexpected events. It's pretty standard in the industry now to develop, to do a risk evaluation of what could possibly go wrong. In other words, at the beginning of a job, try to think outside the box and do some sort of a risk analysis. And in fact, the best practice is to do a risk analysis. So that's, I think you have to do that on virtually every job. And some of those risks will manifest themselves. And some of them, frankly, won't. And some of the things that do happen were never on your risk register. So I always like to put on my risk register the things that you didn't anticipate happening. But it's guaranteed that something unusual will happen on virtually every job. And if you've got your risk register, then you've got already got an action plan or contingency plan on how you're going to deal with it if, in fact, it happens.
Great, thanks, Bill. Next question reads, please share your experience with design bid build versus design build. For tunnels, does one style work better?
Oh, I don't know. That's a bit of a loaded question, too. The standard design bid build method for tunnel construction typically gives a significant amount of design to the contractor anyway, because usually the temporary construction facilities are designed by the contractor because they're not permanent. So in my opinion, the standard design bid build method has a lot of contractor design in it. The design build method will actually transfer some permanent structures design over to the contractor. So, and that's just a little bit more design going to the contractor team. I guess I have sort of mixed emotions about whether that's a good thing or not. Certainly, if the owner can lay out its criteria well enough that the designers know enough to design it without going around several times the block, I think it would be. I think it's an excellent method, and it certainly offers some innovation for the contractor. So, I mean, when I'm thinking design bid build or design build, I guess I'm really thinking what opportunities are there really for the contractor to do innovation. And if the contract has various opportunities for innovation, he can do it way X or way Y or way Z, then I think those are pretty good opportunities for design build. If on the other hand, in order to get permits or in order to build a job or in order to satisfy the community, you can only do it one way. There's only one way to do it. Then the opportunities for innovation are not there, and it probably doesn't make as much sense to do design build in those circumstances. You may as well do the detailed design on the owner side, concurrent with getting the permits, and then just give it all to the contractor and say, build it this way.
Great, thank you, Bill. The next question reads, NEBT alignment appears to run under a congested, urban environment as opposed to along the river. Anything keep you up at night over this difference?
Well, I don't think it keeps me up at night, but it's a lot different. There is the NEBT alignment does go under stuff that we haven't had much of so far on the 3 contracts that we have out there. It goes under a lot of heavy trafficked areas. So handling traffic, moving traffic around in heavy commuter arterial will be a big factor in the NEBT alignment. So far our tunnels have gone under military bases and under the river and under marinas and small residential areas, but the NEBT alignment will be challenging from a traffic control standpoint, that's for sure.
Great, thanks, Bill. Next question reads, in building construction, we have an integrated project delivery method, which encourages collaboration among the project stakeholders. Do we use a similar project delivery method in tunneling projects?
We have a collaborative, well, I think there are ways to get collaboration amongst all the project participants. Clearly the best way to get that project, the best time to get that collaboration amongst all the project participants is before the prices are established. And in building construction, that's quite easy because much of the building construction is done before the final price is developed, if it's a construction manager at risk type contract. But in the tunnel construction, you really need to have early contractor involvement or some sort of collaboration process where the bidders can talk to the owner staff and the CM staff to try out various different methods before they put the price on the job. And we found that to be a very useful element in the procurement process that we've done here at DC Water. So I guess I would recommend any owner's agency, if they're doing design bid build or design build, to try to put in some sort of collaboration process before the price is developed. I think that's very useful.
Great. Thanks so much, Bill. And that's the end of our Q&A session for today. Bill, would you like to make any closing comments?
No, I don't have any closing comments.
All right then. Well, we'd like to thank you once again, and Aaron, for opening up the session today from the UCA Young Members. We encourage all attendees to visit the UCA Young Members site at community.smenet.org/UCAYM. And please reach out to Bill if you have any further questions that you didn't get answered in today's session. Thanks so much, everybody, and we'll see you next month.